Welcome to GC Connect. In the previous class, we were discussing about some problems. I hope you have calculated or you have carried out that rest of the two problems. So we started with the some of the testing of concrete materials. So initially we started with the cement properties or cement testing. What are the test has to be conducted. So properties we'll discuss later, which are the properties that are very much essential for the uh, for giving any of the strength or some of the uh, definitely it is going to help during the concreting process. So we discussed some of the field testing methods, how exactly it can be carried out, and we started with the laboratory testing. In the laboratory test, we um, mm, did with fineness test. So of course, how this fineness or the finer the materials, how it is going to affect the surface area. That is, um, normally it is given by specific surface area. I already told that. It is SSC. How the finer finer the particle, how it is going to affect the specific surface area. If the size of the particle, normally we discuss about the size of the particle. If the size of the particle is go on decreasing, the SSA will increase, and it is normally given by meter square per kg. Means per kg of cement, how much area it is giving. So, and the variation of the size, it will vary from even 1.5 micron to 100 micron. And always I said that the gradations are very important. So and we observed one graph also, that is up to some point here you can see till up to here 300, um, that is a specific surface area, that is meter square per kg. So it will be increased. Then after that, definitely it is going to be flat. So it indicates that even the size of particles is play a very important role. And always the um, size and shape, it can be determined by with the help of the SEMMTM. Surface area, it is determined with the help of the BAT method. Um, so of course in the but accurately we can determine with the help of this high-end equipments, whatever the scanning electron microscope and the transmission electron microscope. So that is BET stands for Brennett, Emmett and Teller. These are the name of the scientists. So then we discuss the sieve test. Very simple sieve test, how exactly it can be calculated. So then permeability test. It is similar to the permeability test what we'll do it in our soil laboratory. So then standard consistency test. So the consistency of the cement, it is determined with the help of the VCAT apparatus. So how exactly it is determined? The standard consistency of the cement paste is defined as that the consistency which will permit a weekend plunger having 10 mm diameter and 50 mm length to penetrate to a depth of 35 mm from the top of the mold. See, um, it has to penetrate with a depth of from the plunger, whatever the weekend plunger it is having. See, of course, in the examinations, no need to go in detail. So maybe he will ask that explain the different tests are going to conduct on the cements. To give some priority, okay, just list the different tests on cement and write uh, main specifications, what apparatus you will use. So what are the specification of that apparatus and what exactly the final uh, thing you are going to do in that apparatus. So just mention whatever weekend plunger will be there. What it is having 10 mm dia, then it is having 50 mm length. So it has to penetrate 30 to 35 mm in the cement paste. Okay. Then what is the use of this? It is used to find out the percentage of water required to produce the cement paste of standard consistency. So this will call the normal uh, So how much percentage of water is required to required to produce produce a produce a cement paste of standard consistency. That normally we will do it in this apparatus. So or what we'll do is that if you're not getting any imaginations, so whenever the offline classes will start, that time I'll take you to the laboratory. So it is there only we will have one type of demo. So then of course this is the procedure how exactly you have to do it. So how much gram you have to take it. So then how much water you have to take it. How much how you have to make the paste and whatever the normally weekend mold will be here. That mold it will be there. It will be there. So there how you have to fill it. So take around 500 grams you have to take it. Then fill that with uh, that mold. After filling, shake the mold to expel air. So whenever you are doing it, make sure that the air has to be taken out. Why you have to shake means the reason behind that the air should not be there inside it. Okay, a standard plunger of 10 mm diameter and 50 mm long is attached and brought down to touch the surface of the paste and quickly released. So what you have to do is that slowly you have to touch that surface. Assume that this is and this is your needle. This is your needle. So what you have to do is that immediately you have to release it. Whatever this needle will be there, just let it be touch the surface and immediately you release it. Okay. Then how much it has to penetrate. Note down the reading according to the depth of the penetration. Normally here the gauge will be here. The gauge will be here with the graduations at this. So just note down that. Then according to our definition, what it has to penetrate with the 33 to 35 mm from the top of the mold. Okay. So then for this, how much water I have used to make this standard consistency that you have to note down. Okay, very simple experiment. So then conduct trials continuously by taking different water cement ratios till the plunger penetrates up to depth of 30 to 35 mm from the top. So better mm, water to binder ratio or water to cement ratio. Okay. Okay. So don't do it blindly. So just you follow from a ratio of zero point 0.4 to zero point 0.5. Normally you will get the standard value if you followed this procedure. Do not take with the ratio of 0.12. Again, it is you won't get that much standard consistency. As your IS code also, it will specify that it is 0.45 water to binder ratio. Okay. The particular percentage is known as the percentage of water required to produce the cement paste of standard consistency. This is usually denoted by P. Okay. Then what exactly the conditions are required? So it has to be conducted in a constant temperature of 27 plus or minus 2 degrees centigrade and constant humidity of 90%. Of course, this is very difficult to follow, but still, what they will say is that most of the time, um, if lot of variations in the temperature or surrounding temperatures in your laboratory, um, if it is 35 40 degrees centigrade, what will happen? The heat of hydration or whatever the what we can call it will be always it is going to increase. Normally, it should not be too cold. Also, it should not be too much of heat. Also, if you are conducting the test in 40 degrees centigrade or 45 degrees centigrade, see we have to see the heat of hydration, heat of cooling also in both the cases. So consistency has to be maintained in these two. So that is why always this has to be. Of course, it is very difficult to follow this. Sometimes it will be 32, sometimes it will be 35. Okay, so that always 5 to 10% error that always it will be there. So you have to consider all those things. So then initial and final settling time. So what is this initial and final settling time? So it is uh, actually very important to test to be performed on the cement. Both the parameters are required before using of cement for any of the purposes. Note down initial settling time as well as the final settling times are very much important for the uh, how much uh, or if you are using it for any of the purposes. This property is more important than the previous one. Okay, so what is this initial settling time? So initial settling time gives and it is give an idea about how fast cement can start losing its plasticity. So how fast initial settling? How fast the cement is losing its plastic plasticity, and the final settling time it gives how much cement takes to lose its very important here how fast the cement losing its plasticity and the final settling time it gives an idea about how much cement takes to lose its full plasticity and gain some strength to resist the pressure. Okay, very important. Time, final settling time. This one is how fast the cement can start losing its plasticity. The final settling time it gives an idea about how much cement takes to lose its full plasticity, and we will discuss that what exactly this time is, or you can say it is in other way. It is, we can define in other way also. So we can define initial settling time is the time lapse between the moments that the water is added to the cement to the time that the paste starts losing its plasticity. Same final settling time, it is the final settling time. It is a time lapse between the moment of water is added to cement and the time when the cement paste loses its plasticity completely. Very important. Loses its full plasticity completely. Plasticity completely. Now, how exactly we are going to conduct this? So, if you know how to conduct this experiment, then it is very easy to uh, find out. So, then initial settling time. It is a time lapse between the moment that the water is added to the cement, the time that the paste starts losing its plasticity. Normally, a minimum of 30 minutes has to be maintained for mixing and handling operations. 30 minutes has to be maintained for mixing and handling operations. It should not be less than 30 minutes. Means uh, this, if you want to analyze it, minimum mixing option operation has to be did for the 30 minutes. Then final settling time, it is a time lapse between the moment the water is added to the cement and the time when the paste has completely lost its plasticity, okay, and has attained a sufficient firmness to resist certain defined pressure. Okay, so final settling time means it is almost, it is like what hmm, normally it is a 590 or 600 minutes. It will be the optimum as for the IS code. We just convert that into hours, 6 to 8 hours, or 8 to, it will be can take 10 hours if you keep it for after concreting. Normally it will become firm, so that only we can call it as final settling time. Okay, so these two words you have to always remember, that is how fast the cement losing its plasticity, so then full plasticity completely. Okay, it is time taken by the cement to resist a pressure, any external pressure if you apply after concreting. So normally it will be there. Okay, and it should not exceed 10 hours so that it is avoided from the least vulnerable to damage from the external activities. Okay, whatever the final settling time is there, it should not exceed 10 hours. That is why even if you see your IS code, it will say that from it will be 400, uh, somewhere 80 to 600 minutes will give. Okay, we will see the some of the um, the standard limits of all these parameters. What IS code will refer it for all these tests. Okay, I'll show you at the end. So what exactly the limit, how much it will be there. Okay, then same weekend apparatus as used for finding the settling time. Okay, and So same, the gauges will be there. So then take a sand and cement of 1.3 ratio of cement. That is, one is of cement and 3% 3% of sand. You have to take it, mix them for a minute. Then you add the water, the quantity, uh, with the P by 4 plus 3%. This P we already noted down. What is P? Here you can see. Okay, for this standard consistency, that is P, and nothing but P we have used it. So mix three ingredients thoroughly until the mixture is uniform in color. The time of mixing should not be uh, less than 3 minutes and uh, greater than 4 minutes. Should not be. Okay. Then the mortar is filled into the cube mold of 7.06 centimeter. Compact the mortar. To keep the compacted cube in a mold at the temperature, before first you have to prepare one mold. Okay, and keep it the temperature of 27 plus or minus 2 degrees centigrade and at least 90% of the relative humidity for 24 hours. So after 24 hours, cubes are removed, immersed in a clean fresh water until are taken for testing. That you have to do it. Okay. So then soundness test. That is a very important parameter. Cement after settling shall not undergo any appreciable change of the volume. This will tell us about the changes in the volume. How exactly the change in the volume is going to happen um, after setting. So this test is to ensure that the cement does not show any subsequent expansions. Okay. So of course, the change in the volume, the ratio will be calculated. Okay. Um, what will be the initial volume and what will be the final volume? Okay, always 1 to 2% that is allowed for the expansion, that we have to take care of. Okay, the the unsoundness in cement is due to the pressure of excess of lime combined with the acidic oxide at the kiln. Okay, normally whenever the cement is in kiln process. So suppose if you um, know that the composition of cement, that is CaO, that is CaOH twice. These two are very important. Or CaOH twice. It is hydrated lime, and this is lime oxide. It is unhydrated. This is hydrated. Okay. Suppose if your problem you are facing in the soundness test, it is completely due to the presence of excess lime combined with the acidic oxide. So then make sure that we'll use this. Okay. Um, and one more thing, uh, it should not be too much exposed to the water. That we have to think it of. So if any problem is happening in the soundness test, is that it is definitely the problem in uh, the process of manufacturing of the cement system, that is going to happen in the kiln process. So this is due to the high proportion of magnesium and calcium sulfate. Okay, even magnesium is also very important as well as the calcium sulfate, CaSO4. Therefore, the magnesium content in the cement is limited to 6%. Okay. So then that the limited proportions will be there. Okay. So this is setup of the soundness test. Okay. Then heat of hydration. Cement with water is an exothermic reactions. Okay, we have two types of reactions. The one is the endothermic and exothermic. So endothermic heat is absorbed. This one is heat is heat is released. What will happen is the cement with water is an exothermic reactions. So what you can see, you can observe. If you take the cement plus mix with water, okay, immediately you can see some type of small bubbles, and okay, slowly it will become heat. Okay, bubbles are going to released, means something is coming out from the cement mixture. Okay, it is nothing but the heat is releasing. Okay, heat is releasing. The heat of hydration will be found out using thermoflask. Okay, about means how much it is going to heat is releasing, that we have to find out using the thermoflask only. About 120 calories of heat is generated in the hydration of 1 gram of cement. So if you take 1 gram, so it is 120, it is 120 calories of heat. The temperature rise about 50 degrees centigrade is observed, and this causes is definitely in the serious expansion of the body of the dam. In most of the cases, care has to be taken in not only in the any of the dams. Okay, the care has to be taken uh, while doing the test. I think so. How much temperature is going to rise? Normally, the mixing water temperature, if you see, it will be mixing water temperature. When you mix the water, the normal temperature is around 30 degrees centigrade, 30 to 35. This is the ambient temperature, the water. Because slowly, if you check that after mixing, so slowly it will rise. So the reason behind, so the heat is released when you mix it. Okay, so it is up to the 50 degree centigrade. Okay, so we are not going in detail uh, about all these tests. Just we are uh, touching all those tests. So how to avoid this? Okay, so lean mix is required, pozzolanic cement is required, artificial cooling of the materials is required. Okay, so then incorporation of the pipe systems in the body of the dam. and applying a cold brine solutions. If this kind of things are going to happen, I already said that this heat of hydration um, in the concrete dams is a normal problem, but how exactly this can be taken out? So these are some of the things we have to um, keep it um, in mind whenever the test of heat hydration or heat of hydration property you are studying. Then let it be some of the things like low heat cement you can incorporate. Okay. Then what you will say that it should not exceed 65 calories per gram. Means what is previously what we did, it is the 120 calories. Then what he's saying is that it should not exceed 65 calories per gram, and it should be less than 75. Again, the depends on the curing time for 7 days, the standards, and 28 days. 7 days, what he will say that it is 65 calorie per gram. 28 days, calorie per gram. Okay, means it should not exceed and should be less than, it is less than, these two words are very important. It should be less than 75. This one is should not exceed. It is should not exceed. Okay. So means as far as possible, uh, low heat low heat of hydration cement has to be preferred. But most of the time, uh, assuming that if nothing is happening, if exothermic reactions are not happening, the cement and the water has the property of the exothermic reactions. The reaction has to happen, but make sure that it should not be like it should not be 0 calories per gram. Okay, the heat has to be released, but uh, some heat has to be released, but it is the boundary is 75. Okay, that much you have to take care of. Okay, so then chemical composition um, is of course this is also a very important thing. It is very important than chemical test, than any other all those properties. If all proportions of cement are in proper way during the preparation in the kiln process, or if you added all the proportions in a appropriate manner, definitely mm, there will not be any problem with the other properties what we have discussed. We discussed about the initial settling time, we discussed about the final settling time, we discussed about the heat of hydration, we discussed about soundness test, and we discussed about the surface area and how exactly it is going to affect all these things. If all these are proportions um, in a proper way, so definitely the all the things will be in um, proper manner. The normally main compositions, let it be is the elemental compositions. First one SiO2, CaO, Al2O3, then Fe2, O3. These four are the main components. So this is also in a very important. This is main component. Of course, lime is required. Aluminum in very least percentage. It will be in all these proportions will decrease as it will move downwards. Okay. Silica percentage is also very important. So that is calcium oxide. That is unhydrated lime. That's also very important. And aluminum oxide, alumina. Normally we can call it alumina. Then that is small traces of Mg. It will be there, but that will not be considered. They are all trace elements in the chemical composition. Okay. So this chemical composition test is very important. How exactly it has to be determined experimentally in the laboratory. Of course, it is very difficult to find out in your lab. It is not there. Okay, it has to be either it has to be done in the advanced lab. Okay, or you can do it in environmental lab with the help of titration. Titration. So the method of doing this, um, it is similar to the to find out the soil chemical composition. The process is soil chemical composition. Similar, almost 90% similar. Suppose if you want to find out the chemicals that are present in soil, the same procedure will apply to find out which are the chemicals that are present in the soil. Suppose if you are using any of the advanced equipments, uh, one equipment is there called um, XRD or EDX, EDX or X-ray reflection or EDX. We will use for finding out the chemical composition. Of course, in detail, how exactly we'll do it, and I'll show some real things how we did it for cement, how exactly it can be calculated in the next class.